This is Mansa. Today I am going to present on Internet Protocol version 4 and Internet Protocol version 6. The two Internet Protocol versions. This is Mansa. Today I am going to present on Internet Protocol version 4 and Internet Protocol version 6. The structure will follow on introduction, explanation, diagram, flow of diagram, comparison, pros and columns, conclusion. In the two Internet Protocol versions make communication possible over the Internet, we all understood how data travels across networks, what IPv4 and IPv6 are, and why IPv6 was introduced. The Internet Protocol works at the network layer of OSI model. It handles addressing, routing, and delivering packets from one computer to another. Every device has unique IP address just like your home address. In this versions, two main versions, IPv4 and IPv6. IPv6 was introduced to overcome IPv4 address shortage. Now, IPv4 will explain. IPv4 is the older version. It was introduced in 1981. It uses 32-bit address, that means 4.3 billion unique addresses. Example 192.168.1.1. It uses classful addressing. The header has 20 to 60 bytes depending on options, still widely used in globally. You can see the IPv4 header diagram here. IPv4 packet has several fields. Version identifies protocol version. TTL, time to live, prevents packets from looping endlessly. Protocol tells which transport layer protocol is used, TCP or UDP, and checksum detect errors. The source and destination fields holds IP address of sender and receiver. Flags DF MF 3 bits control fragmentation. DF equal to don't fragment, MF equal to more fragments. Fragment offsets is 13 bits. Position of fragment in the original packet used to reassemble fragments. The workflow of Internet Protocol version: data from the source host divided into the packets. Each packet gets an IPv4 header with source or destination address. Routers reads from the header, forward the packet. If packet size exceeds MTU, fragmentation occurs. Packets reach destination reassembles, checksum verified. IPv4 is simple, fast, and supported by all devices. But it has clear limitations: limited address space, no built-in security, and poor quality of service. To keep it alive, we use DHCP and NAT, but that's only a patch, not a permanent fix. Now, look at IPv6. Introduced in 1998, it uses 128-bit addresses. That means 3.4 into 10 power 38 unique addresses. It also has a simplified header of 40 bytes and built-in IP security for support. Example 2001:0 0DB8 colon 85A3 colon 8A2E colon 0370 colon 7334. It can auto-configure and provides efficient routing. IPv6 has fewer but smarter fields. Version has 4 bits, always set to 6 for IPv6 packets. Traffic class defines packet priority. And QoS flow label improves performance for streaming or real-time data. Payload length. Next header, HOP limit and source or destination address. It removes checksum to speed processing. The workflow of Internet Protocol version 6 data is encapsulated in Internet Protocol version 6 header simplified. Routers forward using next header field. No fragmentation by routers done by sender. Uses flow label for identifying streams. Better multimedia support, security and configuration handled automatically. The flow label field improves QoS for real-time traffic like video calls. To overcome this, IPv4 with this IPv6 has vast address space, built-in Internet Protocol security, better QoS with flow label, auto configuration support, simplified header improves speed. Comparison of IPv4 and IPv6 addresses are 32 bits in length. In the IPv6 has addresses are 128 bits in length. The IPv4 has deployed in 1981. IPv6 has deployed in 1999. Addresses format is dotted decimal notation. Addresses format is hexadecimal notation. In the IPv4 has both routers and sending host fragment packets. In this IPv6, router do not support packet fragmentation. Sending host fragment packets. Header includes checksum. In this IPv6, header does not include checksum. In this IPv4, header includes options. In this IPv6 has optional data is supported as extension. Configured either manually or through DHCP. In this IPv6 does not require manual configuration or DHCP. In the IPv4, broadcast addresses are used to send traffic to all nodes on a subnet. In this IPv6 uses a link local scope all nodes multicast address. To conclude that IPv4 brought internet to life, but it cannot keep up with today's demand. IPv6 solves scalability, security, and performance issues. Both versions coexist today through dual stack tunneling and translation techniques. IPv6 is the backbone for future internet. In this, IPv4 is still dominant, but IPv6 ensures the security and performance. Thank you.